Hey everyone, welcome to problem number 15, threesome. Okay, so given an integer array nums, return all the triplets nums I, nums j, nums k, such that I is not equals j, I is not equals k, and j is not equals k, and all of them kind of add up to 0. Okay, notice that the solution set must not contain duplicate triplets, which is a great thing. Okay, so given the nums array to be -1 0 1 2 -1 and -4, we got to return the triplets which add up to 0, right? So what are the constraints? So the nums length, so the array length goes from 3 to 3000, and the integer itself could go from negative 10 raised to 5 to positive 10 raised to 5, so it could be like a big number as well. Okay, fair. So couple of things here. So notice that the solution set must not contain any duplicate triplets. So the data structure that comes in is set, so final would be a set. Okay, we don't have to worry about the base condition because the nums length is gonna like minimum of 3 and maximum of 3000 as well. So couple of things what we can do. So we don't actually care about the indices I, j and k. We care about the values at the indices because we eventually gonna check the sum from there, right? So that should ring the bell. So so we plucked out two queues. First, the final data structure must be set, and then the indices actually don't matter. The values in that should matter. So if that's the case, then we could just do nums dot sort. That would uh, that would give you the less values in the front and high values in the back, and again the indices don't matter. So again, the simple method of two pointers could kind of come into the picture. What we can do is keep a pointer as we iterate through the nums array. We'll keep a pointer, say I, and j would be initialized as I plus 1, k would be initialized as nums length minus 1, and then we will kind of keep on incrementing or decrementing. So say we have -1 0 1 4 after sorting, and say 5. We wouldn't care if the sum is kind of going on to be greater than 0, okay, because we want the sum to be exact 0. So that's why, so in case if say I val at I plus val at j plus val at k, if it is less than 0, then we will increment j plus equals 1. Else if it is greater than 0, we will increment, oops, we will decrement k value, assuming, so this is I, j is initialized as I plus 1, k would be initialized as all this stuff. So yeah, I think it's my dog. Okay, anyway, that's there. And what if the value kind of match, so to be equal to 0, then we will just increment 1 and decrement k. Fair. That's basically to it, and then append in the result value as well. Oops, final plus equals value of I, value of j, value of k. Fair. No, I think it should be in dot add for set, right? Yeah, that's basically a gist to it. That's our pseudocode, and let's start writing the actual code. So now we have nums to be sorted, so nums dot sort will sort the numbers in Python. So for I in range 0 to ln of nums -1, and final equals set already done. Then um, if okay, this is what I have to write it as nums. Nums of I, nums of j, so k. Oops, before that, k equals I plus 1, j equals nums of, oops, -1, and while okay, hang on. J is less than k. Fine. Okay, so if it is less than 0, then we'll increment j. L if nums of ijk is greater than 0, will decrement k, else, so that means they are 0. We'll do final dot add nums of I, nums of j, nums of k, j plus equals 1, k minus equals 1, and at the end we'll return the result. Okay, let's see if it works. Oops, my bad. Okay, submit. And it goes through. Perfect. Yeah, that's approach for the 3 sum. Well, thank you so very much for tuning in, and see you guys in the next video. Cheers.